Alright, so let's do some graphics in Lisp today. So this video, just as a preamble, is a result of a conversation I've been having with a couple of people, and I thought it was a good idea to make a video on the subject where I touch on a specific point that they asked, which is what do I like in a interactive living system, and what the hell is that, right? So the idea is that I'm trying here today to bring something that is more approachable to the average programmer. The point is, I raised this argument. I wouldn't even say argument, but I touched on this topic on my new Shepherd video, where I was talking about this idea of having Emacs, right? So when you think of an operating system, an interactive system where you click on stuff, you actually are not really invited to explore the internals, right? So Windows, when you open Windows, you can't just go to the kernel of Windows and like modify stuff and on the fly, right? That doesn't happen. You can make drivers and etc. That's true, but you are not actively a participant of the execution of the program. And I think that's a different story with tools like Emacs. With tools like Emacs, because they do actively invite you to explore things around. And I want to bring something using Raylib. So there's this project here I've been working with a couple of friends, and essentially what it is, that's too big, is a visual novel, okay, for promotional material for a couple of projects that we are running right now. And we're trying to tell the story of the thing and like have a good time developing a game that we can be proud of on telling our journey on designing this database and this language for the Beam that we've been working on. It's been going for more than a year by now. So anyway, and I felt like Raylib is a perfect example because most people nowadays, they are familiar with the thing. It became very popular because it's very easy to port, right? It's just C, so you can just embed everywhere. And somebody was kind enough to provide common Lisp bindings for Raylib. So let's just use that. I already have it all set up. And I just made this file called cube, like apart from everything else. And what it does is that it essentially tries to design that rotating cube you can see squished on the above. Let's connect here. So let's do this. And let's change to VN because that's the package we're in. And let me clear this up and zoom in a little bit. So you can see here that we have this class that is a cube. So that defines the size, angle, speed, color in RGBA, X, Y, and Z coordinates, and it's as well as its accessors, right? So if we see, we have here defined this variable that is exposed to us. Mind you, I just connected as a repo with a repo. This guy is connected on this thing here. So I can actually inspect things that are in there. So if I do this, that is the cube. And then if I click, I can see all the properties of that cube, right? So I can see like, oh, okay, so the speed of this guy is this thing. So you can modify, you can browse around. We can also access with those accessors up there. So we can do, let's pick speed. And we're going to do on the variable with earmuffs. And we get 45, right? But we can do also set F. So we're going to set on that region. Let's put like 100. So that increased a little bit. Let's put 500. That's much faster. 10,000. Well, 1,000. That's much faster. So you can actually modify on the fly the object that is already defined, right? So you can do that with basically every object that is in here. We have the camera defined. We have this thing that calls the update. So for every frame, it keeps updating. Then there's this code here that draws the scene, right? And what it's doing is that it's basically picking the sizes, setting the wires. So you can, let me spin like something that we can actually see, right? So for example, it has wires, like white wires. We can omit that, and if we recompile, there we go. So the wires are gone, right? So you can actually explore the thing and do your stuff. But I think this is extremely valuable, especially for this kind of task, that you need some sort of adaptability, right? So this gives you a very fast feedback loop to interact with things. So let's try to do something to actually command the thing, like to control the cube, right? So let's first do a function here that we're gonna call, I guess, control cube, and there we go. And control cube will essentially receive a key, and we're going to do a condition, and we're going to check if it's equal, and that is just a symbol, so I think it should be safe to do this. And I think Raylib has a bunch of keys, right? So if there's this function here, I was taking a look, and then get key pressed. That gives you just the key that is pressed. Right now, I didn't press anything, so that's going to be null, right? But that is the function. So we're going to use that. Let me leave that here. Oops. Let me leave that here. So if we press right, yeah. So if you press right, that will be equal, so that will fire this condition. And what we're going to do is essentially just do a set f of the, for pressing right, we need to increase the x. Let's just do the x. I mean, the camera is rotated, so we would have to transform the thing. But let's just do one thing at a time, right? So we're going to set the cube x, and then we're going to need the cube. That's a global variable we have there. And we're going to actually increment that. So there's an increment function in incath, if I'm not mistaken. So if we pass, actually I'll be very explicit. So let me do this because people might not know this. So we're gonna access that, and we're gonna have to update the values. So we're gonna have to pick that up again, right? So we're gonna pick that up here. So that's going to pick the value and increment with 1, right? So if we see this, that is 1. So the value is 0, I believe. It's on the center. And we're just increasing. So if you put 10 here, that's 10. Cool. So it's going to increase 1 in 1 and set on that position. Nothing really extraordinary there. Okay, so the idea here is very simple. So let's make another condition for the right? So let's do that here. Let me actually cut this. And then paste it here. I swear I deleted. Oh, right, it's cutting. It's word wrapping, but that's fine. So let's do left. And instead of increasing, we're going to decrease. So if you go to the right, we increase, left, we decrease. Or maybe, I mean, yeah, that looks okay. It's just going to rotate, change the position it's rotating, right? And that's it. So that's our function. We can define it, control cube. And we can call this control cube function on the drawing scene, right? So right before we draw, we need to find a place to put that event, right? Because we're going to get that event coming, and we need to actually set the thing before. So we need to actually pick that before we pick the X, Y, and Z here. So we could do something like this. We need to call control cube. That's probably not the best way to do it, but we're going to do it anyway. And we're going to call that funny function. So get key pressed. So that would pass the key, and that's going to set the values mutably, and we're going to render this block of this let here, this lexical scope, and this scope is going to get the values updated, right? So if we do this now, and what did I do? And I think I blew up. Let's do a thing here. Program. let's do program. So that is like to make a procedural block, and we're gonna print. So format, I think we can format with nil, so like that prints, if I recall correctly. And we're going to do write. That's it. Yeah. And we're going to do the same here. So let's put here. And left. And I think I forgot the other case, which is the true, right? So if it is nothing that I'm pressing, we're not going to do anything. We're just going to print something to see if it's calling this function. So we can just paste format new default. So that's going to print ferociously. I hope. There we go. Wrong number of arguments passed to the function EQ. That is actually true. So it didn't pass the key to compare. That is very silly. So we should pass the key here. So I'm comparing if this guy is equivalent to the key, right? That makes sense. There we go. So it's back and it's not complaining anymore. There we go. Let me actually put this. That's better to read, I guess. Oh, much better. All right, so we can actually now do stuff. So let me switch here to this. And if I press right, it's going further from the center, right? If I press left, it goes here. Isn't that cool? That is very cool. So like that's the idea. I mean, I can keep going, but I think the point is already there. So there's more stuff you can play around. Like there is probably is key down, is key pressed, is key released. So you can like find the right place to put these things in the place and actually modify them. I could do all sorts of stuff. Like for example, I did the setf here on the speed, but we can do like size, I think, and just set the thing enormously, right? I think 10 is already big. Let's put 5. So you can change the size. Oops. You can modify the thing however you want. That's what I mean with a living system, right? Things are here available and you can inspect them and modify them as they run. This is extremely valuable when you have something that is that requires your attention, right? So right now we're so used to this big feedback loops that we have that we hardly notice how harmful it is to actually take a long time to switch your context to actually understand what's going on whatever, right? I think there was this article I saw recently. If I find that out, I'll put it on the description. But it was an article of a guy talking about how long your CI should take to run, right? And I think the idea is very much the same. It is the longer it takes, the slower the feedback loop is, and the more probable it is for you to lose context of the task, right? You start to lose context inevitably. And I'm not talking about like an LLM context, obviously. I'm talking about somebody like memory, like losing memory, losing track of the subject. If we change subjects like 10 times a day during work, that's going to be very hard to focus on any of those tasks. So the tighter you can make the feedback loop to your programming, I think the better, because that will invariably help you to test the code as you do it. And I think that's very valuable because that allows a lot of brainstorming, a lot of ideas can come out of that, and so on. So anyway, that was it. That was a short video. I think the next one that I'm making is, I was doing this just as a peek. I was doing this, I was working on this project here. Let me actually go to the README, and I don't remember where I put it. Yeah, it's on the tools. and I was doing Perl, right? So the next thing is like why I shouldn't use Python and instead use just Perl. I know that sounds crazy, but anyway, that's it. Thank you for watching and see you next time.